Hello everyone, welcome to the channel. So in this video, we're going to focus on getting started with basics of JavaScript in Google Earth Engine. So we're going to create a composite image from different satellite image representing the nighttime light in various years using the addBands function in Google Earth Engine. So now let's get started. So in this video, we're going to use this for specific data called global nighttime light dataset. So let me explain about this particular dataset here. So the Nighttime Light Time Series version 4 Defense Meteorological Program of Operational Linescan System. So the dataset availability is from 1992 to 2014, and dataset provider is Earth Observation Group. And this is the code you can able to access this particular dataset. So the Defense Meteorological Program Operational Linescan System has a unique capability to detect visible and near-infrared emissions sources at night. So the version 4 of the DMSP OLS Nighttime Light Time series consists of a cloud-free composite made using all available archived DMSP smooth resolution data for calendar years. In case where the two satellites were collecting data, the two composites were produced. The image and data processing by NOAA National Geophysical Data Center, the DMSP data collected by US Air Force Weather Agency. So let me explain about the bands that is available in this dataset. So the resolution of this particular dataset is around 927.67 meters, which is close to 1 kilometer of resolution. So these are the following bands that is available in this particular dataset. So we're going to specifically use this particular band, that is stable light. So this band contains lights from cities, towns and other sites with a persistent lightning, including gas flares. So we're going to use this particular band for our video here. So this code demonstrates the use of the dataset showing the stable nighttime light globally. The image is loaded for 1993 and only the stable band is visualized, representing the artificial light across the world at night. This is useful for the urban studies or understanding the human settlements globally. So to load this global image of nighttime light for the year 1993, so to do that, we define this variable called lights93 equals to earthengine.image NOAA DMSPOLS nighttime light of this particular year, that is 1993. So to visualize the details of this particular image, we define print nighttime light representing this particular the name for this specific layer, and lights 93, which refers to this particular variable. So to visualize the details of this image, we have specified its print here. So let us run this code and let us visualize the details about this particular image. So in the console section, you can able to visualize we have the nighttime lights. So the details of the specific images are given here. The properties you can able to visualize the system asset size, index, and time end and time start. And these are the following bands that is available. We are going to select this specific band, that is stable light, which is unsigned int 8 and which a coordinate reference systems is given here. So next we can add the stable nighttime lights bands to the map layer with a specified visualization parameter. So to add this layer, we define map.addLayer lights 93 referring to this particular variable, and in that we are referring to the bands. So we are specifying this particular band called stable lights, which is given here. We are specifically referring to this particular band called stable lights, and we are setting the minimum and maximum value. You can able to visualize it's given the minimum and maximum value. So minimum is around 0 and the maximum is around 63, which represents the brightness and the contrast of the image. And now to output the layer as lights. So now let us visualize this layer here. We're going to navigate to this option called run, and we're going to click run. So now currently we are visualizing this nighttime light global dataset. So currently we are visualizing the United States of America. You can visualize the major city illuminates its light during the nighttime, which is clearly highlighted in the white color in this image. You can able to see here. So the variety of different cities that is in this particular country, which is specifically is the lights from this artificial lights are picked up by this particular dataset. So which is highlighted in white color, you can able to visualize. And similarly, next we're going to We're going to composite the different global nighttime light dataset of different timelines. So from starting from 1993, 2003, and 2013, we're going to composite the different satellite images belonging in different timeline. So for example, 1993, 2003, and 2013 using the addBand function in which is available in Google Earth Engine. So to basically to create a composite image using a different satellite image for different timelines, we can able to use a specific function called addBands function, which is available in Google Earth Engine. So by combining these years into 3-band RGB image, the difference can be highlighted. So basically in the red channel, we're going to represent as a 2013, and the green which represents the 2003, and the blue which represents the 1993. So in this way, it helps us to study the temporal changes in the urbanization or the economic activities across the globe. So let's start. So we're going to load the images for 3 different years starting from 1993, 2003, and 2013. So the stable light band, which contains which contains the data on the stable and long-term light from the human settlements. So first, we're going to define this variable called lights03, which represents the 2003. So we're going to space the code here, that is earthengine.image. So this specific code will access the nighttime dataset here. And in that, we're going to select this specific band called stable light band, which is available in this dataset here. Let me show you once more time. So in this band, we are specifically selecting this particular band from this dataset. So we are selecting this band called stable lights. So that's why we mentioned as dot select stable lights, and we're going to rename as 2003. And similarly, we're going to add the variable, define another variable referring to the satellite image of nighttime dataset for 2013. For that, we define this variable called lights13 equals to earthengine.image. We are mentioning the code here. And in that, we are selecting this particular band called stable lights, and we're going to rename as 2003. So you can able to see that we are using the image of 2003 and we are using the image of 2013. So this variable lights03 and lights13 stores a nighttime light satellite image for the year 2003 and 2013. And next, we're going to create a composite image that compares the stable light across 1993, 2003, and 2013. So to create a composite image of to compare the different nighttime light across these years from 1993 to 2013, we define this variable called change image equals to lights13 referring to 2013 dot add band. We're going to add band, that is lights 2003, 03 represents 2003, and dot add band. We're going to add another band, that is lights 93, which represents 1993 nighttime lights data. And in that, we're going to select the specific band called stable lights, and we're going to rename as 1993. So basically, the addBand function, this method is used to combine different images into one multi-band image. Each band in the final image represents the nighttime light data for the specific year. So to visualize the details of this image, the metadata property of this image, we define print change image. So output the layer as a change image, and referring to this particular variable called change name. So this is the change name. So now to visualize the details of this particular image, we're going to navigate to this option called run and click run. So now here the layer name is change image. So referring to this in the console section, we can able to see the change image. So I'm going to click this arrow here. So you can able to visualize the bands that is available in this image here. So we have managed to add the 3 satellite image as a stack layer using this particular function called addBands. So you can able to see the bands that is available now. It's 2013, 2003, and 1993. And similarly, in the properties, you can able to see the asset size, index, system index, and time start and time end. So next, to add this layer into Earth Engine, we defined as add the composite as an RGB layer. So we're gonna add this as it as a RGB layer. So the RGB layer, so red band, red channel consisting the 19 that is 2013 image, and green band which contains the 2003 image, and the blue channel which contains the 1993 image. So to add this layer, we define map.addLayer change image referring to our this particular variable, and with setting a minimum of 0 and to a maximum of 63. So the minimum and maximum which represents the brightness and the contrast of the image, so which is given in this particular dataset. So minimum and maximum is given here, and output the layer as change composite. So we're going to visualize this particular result here. So basically, in this case, we're going to visualize the nighttime light intensity across three different years from 1993, 2003 to and 2013. So basically, the nighttime light intensity across 1993 to 2013. By combining them into a single image using the addBand function, so we can analyze the changes over the time. So we're going to run this, navigate to this option called run and click run script. So now we're gonna close this here, and to the layer section, you can able to visualize we have two different layers. So the first layer which represents the, let me show you that. The first layer which represents the 1993 image of nighttime light global dataset, and the change composite which represents the entire the image, the composite image of 1993, 2003, and 2013. So we're gonna turn this on. So I'm going to navigate to this particular section here. So this particular city, you can able to visualize it now here more clearly. So this is the current state. This is the state of the status during 1993, and this is the status in in 2013. So basically, you can able to visualize the changes here. So different colors which represent the changes. So for example, during the 1993, this particular the white color which visualizes the nighttime the status of this particular city, and in outer areas you can able to visualize that there is an orange like color which represents the 2003, and the further this particular the purple or purplish color which represents the 2013's nighttime status of this particular city. So I'm going to navigate the layer section and click this option here, and here you can able to visualize we have three bands RGB. So the first band which represents 2013, and the second band which represents 2003, and the last band which represents the 1993. So suppose if you want to visualize only the 1993 image, I'm going to select 1993 in all these bands, and once you did that, we're going to apply it. So currently we are visualizing only the 1993's image, and if you want to visualize only the 2003 image, you're going to select 2003 and 2003, and in this band also going to select 2003. So now we're going to visualize it for the nighttime status for 2003. You're going to apply it. So now you can able to see the changes in this city here, and similarly I'm going to select for 2013 and 2013 and 2013 in the three channel. This is red channel, green channel, and this is blue channel, and I'm going to click apply. And now this is the current status of that is the status in 2013, the nighttime status in this city. And suppose if you want to composite all these images together, so for that I'm going to select here, I'm going to select 2013, and I'm going to select 2003 and 1993. And now let's apply and visualize the result here. So you can able to see the changes here. So we have managed to composite the three different satellite images that is belonging to different timelines. So using the addBand function, you can able to composite these three satellite images together, these three different satellite images together using the addBand function, which is available in Google Earth Engine. So you can able to see the changes here. Let me close this. So different color which represents the different timeline, the status of the nighttime light in this particular city, and similarly you can visualize for different parts of the worlds. So you can able to see this we're going to navigate to this particular part here, Philadelphia. So we can able to see here the different color which indicates the different the night time during the different years. So we can able to see using this kind of in a different you can detect the change direction of this stable light across different timelines. So the different color which represents the different status of the stable light across different years. So likewise, you can go through, you can check out this nighttime data for entire world here. For example, I'm going to focus on this particular city here, Moscow. So you can able to see the difference here more clearly in this particular city, Moscow. So there is just you can distinguish the different colors in this image here. For example, this will be the color status in 1993. Let us check that. I'm going to turn this off. I'm going to turn this on. So this is the status in 1993, and this is the change detection of the stable light from 1993 to 2013. So let us focus on the applications of this particular dataset. So let me explain how the addBand function works in Google Earth Engine. So that allows you to combine multiple single band images into one image that contains multiple bands. This is particularly useful when you want to compare the different time periods or the variables within the same spatial area. In this case, we are comparing the nighttime light intensity across 3 different years from 1993, 2003, and 2013. By combining them into a single image, we can easily analyze the changes over time. And applications. So change detection, this multi-band image allows us to detect changes in stable light over years. You can visualize the image or perform the operations like band math to calculate the changes. So you can subtract 2003 from 2013 to see the areas with increased or decreased light. And the temporal analysis. By combining multiple years of data into a single image, it's easier to perform the temporal analysis on changes in urbanization or human activity over time. So the benefit is by using the addBand function, we can create a single image that simplifies the process of visualizing and analyzing changes over time. Let me get back to Earth Engine. So in this video, I have shown you how to create a composite image from different satellite images using addBand function in Google Earth Engine. So thanks for watching, and make sure that you subscribe to our channel and give us a like, and the link is available in the description section of this channel. Thanks for watching.